A ship sails from Port R on a bearing of 65 degrees to Port S, a distance of 54 kilometers. It then sails on a bearing of 155 degrees from Port S to Port Q, a distance of 80 kilometers. Find, correct to one decimal place, I, the distance between R and Q. II, the bearing of Q from R. As we learned in the previous video, whenever you are being given a question like this, the first thing you need to do is to read the statement carefully and then draw an appropriate diagram for the statement. So, let's go over the question again. A ship sails from Port R on a bearing of 65 degrees to Port S, a distance of 54 kilometers. It then sails on a bearing of 155 degrees from Port S to Port Q, a distance of 80 kilometers. So we are going to draw a diagram to represent this information that has been given to us. So the ship started sailing from point R. So it means that our starting point is going to be Port R or point R. Now it started from Port R and it sailed on a bearing of 65 degrees to Port S. So our starting point is Port R or point R on a bearing of 65 degrees, and the ending point is Port S, and the distance between Port R and Port S is 54 kilometers. So let's draw the diagram for this first part. So we are going to consider for this first part, then after that we will consider the rest. Okay, so the ship started from Port R. So we will draw our X and Y plane here, then we indicate here as R or Port R. It started sailing on a bearing of 65 degrees. So we measure 65 degrees from 0. So here's the 0 line. Don't forget that. Here is 0 degrees. Here is 90. Here is 90 degrees. Sorry. Here is 180. Oh, sorry. And here is 270. Okay, so here is 0, 90, 180, and 270. So it started on a bearing of 65 degrees. So it started from 0 here, 65 degrees. Then you draw the line through it. It started from Port R to Port S. It started from Port R to Port S. Now the distance between Port R and Port S is 54 kilometers. The distance between Port R and Port S is 54 kilometers. So the ship started sailing from Port R on a bearing of 65 degrees to Port S, and the distance between Port R and Port S is 54 kilometers. So we are done with the first part. Let's go on to the second part. It says that it then sails on a bearing of 155 degrees from Port S. So for the second part of the journey, it started from Port S. That is why I've drawn the X and Y plane on Port S. So this ship started sailing in the second part of the journey. It started from Port S to Port Q. So the starting point is Port S. The ending point is Port Q on a bearing of 155 degrees. So you are going to measure 155 degrees from Port S. We know that also on Port S, here will be 0, here is 90, here is 180, here is 180, and here is 270. Now we know that 155 is between 90 and 180. So is going to be in this region or in this quadrant. Okay, so you ask yourself, what should you add to 90 degrees in order to get 155 degrees? And you are going to get that by subtracting 90 degrees from 155 as we've been doing all along. And when you do that, you see that you are going to get 65 degrees, because 65 degrees plus 90 degrees will give you 155 degrees. So it means that you are going to measure 65 degrees from 90 here in the clockwise direction. Then you draw your line through it. As I said in the previous video, make sure that your diagram is appropriate. We know that from 90 to 180 here, the total angle is 90 degrees. 65 degrees is more than half of 90 degrees. So draw something that represents more than half of 90 degrees. You are not going to get it accurately because you are not drawing it to scale, but make sure that your diagram is appropriate. So 65 degrees is more than half, it must be shown that it's more than half. So you draw something that is about 65 degrees. Then you draw your line here. The starting point is S and the ending point is Q. Now you see where the arrow is moving towards, showing that it started from S to Q. So in the first part of the journey, it started from R to S. Then the second part of the journey, it started from S to Q. So you have been able to illustrate this information here on the diagram. It says that from port S to port Q, a distance of 80 kilometers. So from port S to port Q is 80 kilometers. Once again, on this diagram, you can see that from R to S is 54 kilometers. From S to Q is 80 kilometers. So make sure that the 80 kilometers is longer than 50 kilometers, because 80 kilometers is longer than 50 kilometers. So don't draw them as the same length, or don't make the 54 kilometers longer than 80 kilometers. When you do that, your diagram will be inappropriate and it's going to affect the answer that you are going to get. The question goes on to say that we should correct to one decimal place the distance between R and Q. So the question wants us to find the distance between R and Q and the bearing of Q from R. In the introductory video on solving distance bearing problems, we said that after you've drawn the diagram for the question, the next thing you need to do is to form right-angled triangles from the question. So in order to do that, you have to find the interior angles of the triangle. So you find the interior angles from the triangle that is possible to find using geometry. So this is what I mean. We know from this diagram here that this point here is the 90-degree point. Here is the 180 degrees point. So the total angles between this point here is 90 degrees. So if here is 65 degrees, then this other angle, that is the smaller angle here, is going to be 90 degrees minus 65 degrees, which will give us 25 degrees. So you have been able to find this angle here. Let's see if we can find this other angle. Now look at something. This line here, this vertical line passing through R, and this vertical line passing through S. These two lines are parallel lines. If they are parallel lines, then the line RS is a transversal crossing the two parallel lines. Because the line RS is a transversal crossing the two parallel lines, we can say that the angle that is created here, which is 65 degrees, and the angle that will be created here will be alternating angles. We know that alternating angles are equal. So if here is 65 degrees, then this angle is also 65 degrees. Once again, I have explained alternating angles and all the other angle properties of parallel lines under the video in plane geometry. So if you watch that video, you are going to get more knowledge about how to find alternating angles and all the other angles too. Okay, so we have here to be 65 degrees and here to be 25 degrees. 65 degrees plus 25 degrees will give us 90 degrees. So it means that in this triangle here, triangle RSQ, this side here, the angle on S is our right-angled triangle. So from here, I'm going to draw a small right-angled triangle that I'll be using for my calculations. Now on this small right-angled triangle, because here is X, that has, because X has the right angle on it, I'm going to indicate that in the diagram. So this point here, point S, has the right angle on it. So point S with the right angle, as can be seen here. Now we know that the distance between S and Q is 80 kilometers. So from the diagram, the distance between S and Q is 80 kilometers. So I will indicate that here, 80 kilometers. We also know that the distance between S and R is 54 kilometers. So I will indicate that one also on the diagram. The distance between S and R is 54 kilometers. The question told us to find the distance between Q and R. So we have a right angle triangle. We know two sides and we want to find another. We can apply the Pythagoras theorem to help us solve this question. In the video on trigonometry, we explained the Pythagoras theorem. We are going to use the knowledge that we got from trigonometry, from Pythagoras theorem under trigonometry to solve this question. We know from the Pythagoras theorem that the square of the hypotenuse, or the longest side, is equal to the sum of the squares of the other two sides. So what this means is that if you come to this triangle here, the square of the longest side, which is RQ, that is the line that we are interested in, the square of that line is equal to the sum of the squares of the other two sides. So the square of RS plus the square of SQ. Okay, so after we have been able to quote this formula, all we need to do is to substitute our values in it. We are looking for RQ. So RQ squared is equal to RS is 54, so 54 squared plus SQ, which is 80, so 80 squared. RQ squared is equal to 54 squared plus 80 squared will give us 39316. So what do you do here in order to find RQ? You take square roots of both sides. So you take square root of the left hand side, then you take square root of the right hand side. Now as soon as you do that, we know from change of subject that if you take square roots of this side here, now the squared here will cancel the squared here. We learned this in change of subject, and we also learned it under indices. So the squared here will cancel the squared here. So RQ is equal to 96.5 kilometers. The distance between port R and port Q is 96.5 kilometers. The second part of our question says that we should find the bearing of Q from R. Now, to find the bearing of port Q from R, we know that the bearing of port Q from port R will be measured from the zero line of port R in the clockwise direction up to the line joining port R to port Q. So it means that we are going to measure it from this side here straight up to this side here. But we know one thing. We know that this angle here has already been found to be 65 degrees. We already know this angle here to be 65 degrees. So what is left of us to do is to find this angle here. If you're able to find this angle here indicated with the red color, we add it to the angle here which is indicated with the blue color, that is 65 degrees, and we'll be able to find the bearing of port Q from port R. Okay, so how do we find that angle here? The angle indicated with red as shown in this diagram. How are we going to find it? I'm going to call that angle theta. I'm going to call this angle here angle theta. So if I call this angle here angle theta on this diagram, on this right angle triangle, I can also indicate theta here. Now look at something. You see that theta, you can see that theta is the angle formed on port R. So here the angle on port R is also theta. I want to find the value of theta. Considering theta, 80 kilometers is opposite, 54 kilometers is adjacent. Considering the angle theta, you can see that 80 kilometers is opposite to theta. 54 kilometers is adjacent to theta. In order to find theta, I'll have to use one of the three trigonometric ratios we've learned under trigonometry: cos, sine, and tan. Now, I have opposite and adjacent. We know that if you have opposite and adjacent, the trigonometric ratio that you have to use is tan, because tan will give you opposite over adjacent. So here, to help us find theta, I'm going to use tan. Okay, so as soon as we are able to find theta, we can say that the bearing of port Q from port R will give us 60 degrees plus theta. So let's find theta. From the right angle triangle, we can say that theta tan theta is equal to opposite, which is 80 kilometers, divided by adjacent, which is 54 kilometers. So the kilometer will cancel the kilometer. How do we find theta? We can say that theta is equal to tan inverse of 80 divided by 54. So all we need to do is to find the tan inverse of 80 divided by 54. We know how to do that, right? You press on shift, then you press on tan. Then you bring your division sign, 80 divided by 54. From there, you close the bracket, and tan theta is giving us 55.980. It goes on and on. Remember, the question said that we should leave our answer in one decimal place. So here I round this. If you are leaving your answer in one decimal place here, you will see that you add 1 to 9. When you add 1 to 9, it becomes 0. So you transfer it to this side, which becomes 56. As I said, if you want to learn how to do this, watch the video on approximations. I explain that into details. So leaving our answer in one decimal place, you are going to have 56 degrees or 56 degrees point 0, which is the same thing. So we have found theta. But theta is not the bearing of port Q from port R. We know that the bearing of port Q from port R is 65 degrees plus theta. We have found theta to be 56 degrees. So what do? The bearing of port Q from port R is equal to 65 degrees plus theta, which is now 56 degrees. And this is going to give us 121 degrees.